Good morning, third grade. Happy Monday. We're starting our second week, and if you notice, it looks a little different in the video because I'm videoing from home. Some of my lessons might be in the classroom again, but they're encouraging the teachers to stay home as much as possible. So I got a whiteboard in my living room, and I am pretending to have school at home. So we'll see how this kind of goes. But I definitely miss my big board and just having all the supplies easy. So we'll kind of see how it goes. But that's why it looks different today. I'm filming from my house. All right, so we are in math today. So make sure you have your Arithmetic 4 book. And we are opened up to page 197, 198. And today we're going to be reviewing divisibility rules. So how we can check quickly on larger numbers if one of these numbers on the side here, 2, 3, 4, 5, 9, and 10, can go into it without having to do the long division and checking, just by doing some tricks. So number 2 is nice and easy because we know that one. A number is divisible by 2 if it's an even number. And who can remember our even numbers? If they end in 2, 4, 6, 8, or 0. So you just look at the last number. If it's a 2, a 4, a 6, an 8, or a 0, it's even. If both are even, then both are divisible by 2. For numbers 5 and 10, those ones are kind of easy. They go together. So if a number is divisible by 5, once again, look at the last number, just like with 2's. But instead of looking for an even number, you're looking for a 0 or a 5. So if the number ends in a 0 or it ends in a 5, it is divisible by 5. With 10, if it ends in a 0, it's divisible by 10. So 5's can end in a 0, 10's can end in a 0, but 5's could also end in a 5. Okay, and you think when you're counting by 5's, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, right? All those numbers either end in a 5 or a 0. 10 is just got to be a 0. When we count by 10's, 10, 20, 30, 40, 50, all those numbers end in 0. All right, number 3 and 9 kind of go together, and which is neat because when we count by 3's, 3, 6, 9, right? You kind of can help you to remember that. If you add up the digits, so you take the sum, remember sum means to add, you add them up, and whatever number you get after you've added them, if that number is divisible by 3, then the whole number is divisible by 3. Or if we're down here, if you add it up, and that number is divisible by 9, then 9 can go into it. So let's look at those two. Those ones are the trickiest ones. So if I add up, if I'm looking at the number 231, and I say, let's add those up. 2 plus 3 makes 5. Good job. 5 plus 1 makes 6. Can 3 go into 6? 3, 6, yes. So that means without even checking, I would know that 3 can go into 231 perfectly. That means there wouldn't be any remainders left over. It would go in exactly. Okay? We'd still have to do long division to figure out what that other number is, but we know it would go in perfectly. That works also for 9. So if I take a sample number like 522 and I add those digits up, what's 5 plus 2? 7. What's 7 plus 2? 9. Well, of course, 9 can go into 9, so that means 522 is divisible by 9 without even having to check. Okay, so with 3 and 9, we have to add up the digits and then check if either of those can go into it. 4 is the last one, and I left it for last because it's got 2 rules. So a number is divisible by 4 if the last 2 digits are zeros, like any 100, okay? 300, 600, 1,800, as long as there's 2 zeros at the end, 4 can go into it. It's also divisible by 4 if the last 2 digits is divisible by 4. So let's look at that. What am I saying? So 324, what are my last 2 digits? 24, right? Can 4 go into 24? Yes. So guess what? 4 can go into 324. Okay, so we are going to look at our paper. Now you can see on the board that I tried to write as much as I could, but because it takes up so much space, I'm going to have to erase and I'll put the next set up. So we're going to do 1A, C, E, and G together, and then I'll erase the board and we'll start the other ones, okay? Now, when we're checking if these fractions are divisible by one of these numbers, we're always going to start with the biggest number on the bottom. Now, some of you might be thinking, well, Miss Roach, I already know the rule for this. Can the top number go into the bottom number? Yes, we could divide by 8, but is 8 a number here? No, and they want us to practice these rules. That's part of the lesson, is being able to see. So even though we know this is going to be divisible by 8 in the end, we're going to try and start with some of those pink numbers over there, okay? So they always want to start with the largest one. So let's look at the 10 rule. Do these end in 0? No. Let's check the 9 rule. Well, can 9 go into 8 perfectly? No. 1 plus 6 makes 7. No, that doesn't work. Let's check 5. Do they end in 0 and 5? No. Let's check 4. Do they end in 2 zeros? No. Are the last 2 digits divisible by 4? Let's see. Can 4 go into 8? 4, 6. I'm sorry, I'm counting by 2s. 4, 8. Yes, it can. Can we count by 4 to get 16? 4, 8, 12, 16. Yes. So we are going to write in this first blank, 8 and 16 are, now divisible is what it says in your book. I put a divide sign to make it a little easier for me. 8 and 16 are divisible by 4, because 4 can go into 8 and 4 can go into 16. So we're going to divide by 4 first. So let's go ahead and do that. How many 4s can go into 8? 2. How many 4s can go into 16? 4. Okay, so now see how they gave us another, because now we have 2 fourths. So now they want us to look. What could go into 2 and 4? What is 2 and 4 divisible by? Well, first of all, guys, 10, 9, 5, and 4, and 3, actually, are all bigger than one of our numbers. So it can't be a number larger than what we're looking at, because it's like when we divide, can 6 kids go into 2 desks and 8 kids go into 4 desks? No. So really the only one we can look at here is the top one, 2. Are both 2 and 4 even numbers? Yeah. So we can divide by 2 one more time. So now I'm going to take this and divide it by 2. So I'm going a step farther. How many 2s can go into 2? 1. How many 2s can go into 4? 2. So my answer here is 1/2. That is my answer for 1A. And we divided by 4 first, and then we divided by 2. Okay, let's try the next one. Let me get a different marker here. Let's use purple. Okay, so 27 and 81. So we're going to start at the bottom here, guys. Can 10 go into 27 and 81 perfectly? Do they end in zeros? No. So let's go to the next one. Sum of the digits for 9. Let's add them up. What's 2 plus 7? 7 plus 2, 7, 8, 9, 9. Can 9 go into 9? Yes, check. So this might work. What's 8 plus 1? 9. Can 9 go into 9? Yes. So we just found a big number that's going to help us. 27 and 81 are divisible by 9. Go ahead and write 9 on that line. And then we're going to divide by 9 here. So I'm going to do 27 over 81 divided by 9 divided by 9. How many 9s can go into 27? 9, 18, 27. That's 3. How many 9s can go into 81? 9 times what makes 81? 9, right? Okay, so now I have 3 9ths. So they want us to take it a step farther. 3 and 9 are divisible by what? So go to your smallest number, 3, and let's check 3 first. If that doesn't work, we'll do 2. Sum of the digits, 9. Can 3 go into 3? Yes. Can 3 go into 9? Yes, there's nothing to add up there. So we're going to divide by 3. Because we have to keep reducing until you can't reduce anymore. That's the rule. We got to get it the smallest it can go. So how many 3s can go into 3? 1. How many 3's can go into 9? 3. So my answer is 1/3. All right, this is kind of a funny way of doing our reducing, right? Okay, let's do another one, E. This is a nice hint here. There's only going to be one way to divide here, so that's kind of nice. So 14 and 26. So let's go through, starting at the bottom. 10. Do they end in 0? No, that won't work. Let's try adding up the digits. What's 1 plus 4? 5. 9 can't go into 5. 2 plus 6 is 8. That won't work. All right, let's check our 5 rule. Do they end in 5 and 0 or 0? No, so 5 won't go into them. Let's try 4. Last 2 digits zeros? No. 4 can go into them. Let's see. Can 4 go into 14 perfectly? 4, 8, 12, 16. No, we don't get 14. How about 26? 4, 8, 12, 16, 20, 24, 28. No. No luck so far. Let's go to 3. 1 plus 4 is 5. Can 3 go into 5 perfectly? No. 2 plus 6 is 8. Can 3 go into 8 perfectly? No. So all that work to get stuck with number 2, even numbers. Are both of these even, guys? Yes. So we are going to divide by 2. And we can do it right here. So I'm just going to do divided by 2, divided by 2. How many 2's can go into 14? 7. How many 2's can go into 26? Ooh, that's a little more challenging. We got it, because I know 2 times 10 is 20. So then 2 times 11 would be what? 22. 2 times 12 is what? 24. So 2 times 13 would be 26. So 13. We had to go all the way up to. So 7/13 is my answer there. All right, they made that one kind of simple because look at the next one. We've got lots of dividing to do. Okay, so we're doing 270 over 810. That's a giant fraction, right? Now, do you notice something about this? What does it end with, guys? Zeros. Well, what do we know? What can be divided by 0? 5 and 10, but we always want to start with the biggest one. So what's bigger, 5 or 10? 10. So let's divide by 10 first, okay? And I'm going to write it underneath here. Hopefully you guys can see this okay? Yeah, I think so. All right, so let's divide by 10. How many 10s can go into 270? Well, remember when we're dividing by 10, all you do is take off a 0. So what's left if I take off a 0? 27. Good. Divide by 10, take off the 0. What's left? 81. Ooh, look at this. That's that same fraction. What did we divide 2780 over 81 by? We divided it by 9, and then we divided it by 3. So let's do the same thing. That actually was kind of nice that they helped us out there. So we're going to divide by 9. It's going to get kind of big here. Let's see. How many 9s can go into 27? 3. How many 9s can go into 81? 9. All right, I'm going to do it down here. So 3/9. And now we're going to divide by, what next, guys? 3. That's right, because it's the same thing we did up here. So I'm going to divide by 3. How many 3's can go into 3? 1. How many 3's can go into 9? 3. Perfect. So my answer is 1/3. All right, good job, guys. Okay, so I'm going to erase this real quick. We're kind of seeing how this goes. Remember, if you didn't get any of that and you need more time, pause the video and make sure you understand and have it all down. Anything that is tricky today, guys, because I would call this a tricky lesson today, I want you to circle it, and when I check in with you later on today or tomorrow, I want you to tell me which ones you got a little bit stuck on, okay, and I'd be happy to help you. Okay, so now we're going to do the next row. So it's B, D, F, and H. All right, so I'm going to get these down, B, D, F, and H. And instead of writing all the words, I'm just going to write the fraction, and we're going to look at what numbers can go into it, okay? So our first one is 5/15. Does anyone see what can 5 and 15 be divisible by? What can go into 5 and 15? Looking at our poster, do you see something that they end with? Or we're looking for ending digits on a lot of these. They both end in 5, and we know that numbers that end in 5 can be divisible by 5. So when you write in that space over here, go ahead and write 5 because we're going to divide by 5. And we're going to do that right here next to it, so we don't have to do it underneath. We have room. So how many 5s can go into 5? 1. How many 5s can go into 15? 3. So my answer is 1/3. Good job. Let's do another one. D. Letter D says 33 over 36. Okay, so we're saying what can go into 33 and 36? So they don't end in zeros. They don't end in 5. Let's try adding them up. Let's see what we get. What's 3 plus 3? 6. Okay, so I'll kind of think that in my head. What's 3 plus 6? 9. Can 3 or 9 go into both of these, 6 and 9? 3, that's right. 3 can go into 6 and 3 can go into 9. So 33 and 36 is divisible by 3. Now, did anyone know that without having to add it up? You just saw 33 and 36 and knew. Very good. But when we have, say I added a 0 to this and made them really big numbers, it might not pop out to you. So that's why we're practicing this, okay? But a lot of you probably saw that and said, Ms. Roach, I already knew that 3 could go into those. So let's go ahead and divide by 3. How many 3s can go into 33? 11. Very good. How many 3s can go into 36? 12. Good job. So my answer is 11/12. Just going to check our time here, see how we're doing. Okay, our videos can be a little bit longer, so I'm going to finish F and H, and then I'm going to have you guys practice the review section on your own on the back, and that way when I check in with you, it's really nice when we can individually go over answers together, okay? But this is the new kind of tricky part, so that's the part I want to make sure that we do together, okay? All right, so letter F is 140 over 150. Ooh, does anyone see something there? That's right, divide by 10, divide by 10. Okay, so whenever we divide by 10, cross out the zeros, and whatever's left is going to be our fraction. 14 over 15 is our answer. All right, and last one, we're going to do 540. You hear Milo barking outside? 540 over 612. Be sure I copied that right. Okay, so we do have 2 numbers to divide by here. Okay, so we got to do it twice. So let's look at our ending numbers. They both don't end in 0, otherwise 10 would have worked. Let's try 9, adding up the sums. What's 5 plus 4? Oh, that's 9, so that will work. Let's see if this one adds up to a number, a multiple of 9. 6 plus 1 is 7. 7 plus 2 is 9. Hey, look at that. So since we got 9s on both of those, we can divide them by 9. So let's do that first. And guys, this is a little bit tricky. 540 into 9. I think we might have to do some long division here. So this is good extra practice. All right, so how many 9s can go into 5? None. I'm going to put an X. How many 9s can go into 54? 6. Very good. Let's subtract that. Bring down our 0. How many 9s can go into 0? 0. And that's our last spot. We know that's going to be 0. So 60 is our numerator. And now we got to do 9 into 612. So let's go ahead and add that up. And divide this up. I'm watching Milo. Milo, get down. This is what it's like teaching. I'm going to close the door so he can't come in. We will let him bark at those neighbors. Okay, all right, here we go. Can 9 kids go into 6 desks? No. Can 9 kids go into 61 desks? Yes. How many 9s can go into 61 without going over? 9 times 6 is 54. That's close. When I subtract, I gotta borrow, right? 11 minus 4 is 7. Bring down our 2. How many 9s can go into 72 perfectly? 8, that's right. So let me raise this up a little. So we've got 68 here. That is going to be our bottom number, and I'm going to do that with our with the black pen so it's easier to see. Okay, so we can actually reduce that one more time. So we got to go back and look. All right, so let's see here. We did 9, so let's go up to 5. Can 0, that doesn't end in a 0 and a 5, so we can't do that. Let's look at 4s, okay? They don't both end in 0. Let's see, can 4 go into 60 perfectly? Counting by 4s. You know what, let's check long division because we don't normally divide by 60 or count by 4s all the way to 60. That's a lot higher. Okay, so 4 times 1 is 4. Oh, look at that. How many 4s can go into 20? 5. So 4 can go into 60. Can 4 go into 68? Well, that's just 8 more than 60, which gives me a hint. We'll see if you guys can get it. Let me erase this right here. Guys, this is a good time to say also that we are probably going to need scratch paper for a lot of this. They don't give us enough room in the book to do all of this math. So I would have a notepad or some blank, computer paper or something next to you so you can do some scratch paper. If you have a whiteboard at home or if you took it from the classroom, you could totally use that too. Okay, so if I divide by 4 here, this is the same number, okay? Can bring down our 8. Can 4 go into 28 perfectly? Yes. 4 times 7 makes 28. So if I divide by 4, let's do it. We already did the long division for ourselves. Okay, how many 4s can go into 60? 15. And how many 4s can go into 68? 17. So, oh my goodness, that is my final answer for H, 15/17. Okay, guys, that was a lot of concentration. Now, we're going to be practicing this throughout the week and doing some other addition, multiplication, fractions, and things like that. But since this is new, I wanted to go ahead and do that all with you and move out of the way to make sure you got all those answers. So, on the back, there's some Roman numerals. There's also some long division. And there's some good homework subtraction of fractions on the bottom. So maybe pick one from each section. If you can do more than that, great. But when I check in with you, I'm at least going to check one from each section, okay? And that way I can give you some help and we can do it individually together if we need it. All right, guys. Sorry that was such a long lesson. I will see you back for language in a little bit. But take a little break, get a snack if you need to, and then try some of those problems on the back. All right, we'll see you in a little bit for language.